All right, it looks like it is 10 o'clock, so we'll let that poll stay open a little bit longer. It looks like we keep getting a few people joining. Again, for those of you who are just joining, my name is Rebecca Ozarian, and I'll be moderating today's webinar. This is the first in a series on prescribed fire for the next 5 weeks, so we're really excited to have everybody here. Today's focus is on fire ecology, and we have two great speakers prepared to share their expertise with you. But before we get started, I do want to make sure everybody knows how to comment or ask questions during the webinar today. As a few of you have been asking, yes, all attendees are muted and have no video sharing access for the whole webinar. We're expecting a few hundred participants, and the servers just wouldn't be able to handle it if everybody had video access. If you're having any technical issues, like if my sound isn't coming through to you well, or if our presenters aren't coming through to you, please comment in our chat box. This is a small message box button on the bottom of your Zoom window. It's going to be right next to the little icon that shows a hand that you can raise. And Max and I will be helping out if you have any trouble hearing or seeing the presentations. Right now, you are just seeing an introductory screen. When our presenters start, they will actually be visible. I'm just the voice behind the curtain today. And then during the presentations, if you have questions about the topic of prescribed fire or the fire ecology topics that are being shared, please write your questions in the question and answer box. It's the Q&A box that has two little speech bubbles at the bottom of your Zoom window. We'll be monitoring the Q&A to make sure we get to all the questions that we can get to today. But just so that you know, all of our questions will be answered during the last half hour of the webinar today. So I think we are just about done collecting responses for that poll. Max, I leave it in your hands when you would like to close the poll. It looks like we're still getting a few responses trickling in. And in the meantime, I'd like to allow our first speaker to prepare to share her slides. So we'll get to the reason you're all here today. Our first speaker today is UC Cooperative Extension Forestry and Natural Resources Advisor, Susie Kocher, who's coming to us live from the Central Sierra near Tahoe. Susie will be talking about fire behavior and fire benefits and the principles of fire ecology. And while you're watching the presentation, you can change the view on top of Zoom to speaker view once her video is available so that you can see Susie while she presents.
Hi, thanks, Rebecca. I haven't started sharing my screen because I wanted to make sure that I wasn't going to mess up the polls. So Max, if you'd like to go ahead and share the results, that would be great. Okay, I am looking this over. It looks like we have quite a few landowners, folks from agencies, academics and nonprofits. We have 15% of people that own or manage less than 1 acre, 26 with 1 to 10 acres, 25% with more than 10,000 acres. And I'm assuming that some of those are some of our agency representatives. And then when I look on question number 3, I've got conifer forest 50%, oak woodland 74%, some grassland 53%, and shrubland 50%. So that's great to know. I think this webinar series is designed for a wide variety of people from different organizations or backgrounds and different vegetation types. So I'm hopeful that we'll be able to accommodate most of your questions and issues. Okay, I'm going to start sharing my screen now. I think I have to share my face before my screen. Sorry about that.
No problem. We see your face right now.
Okay. There we go. There's a certain order that things must be done in.
Great. And yes, for everybody listening in, you can click at the top of your screen to do speaker view. And once I stop talking, it will go to just Susie's face.
Okay, well, thanks very much for having me. I'm glad to be here on screen with you. I am very grateful to my colleagues, Rebecca, Fadzayi, Mark, Sherry, and Max, who have taken what used to be an in-person 2-day workshop and reorganized it so that we can continue to offer very similar content online. One component we won't be able to do that we have been doing with this workshop series is in-person burn demonstrations, at least not in the spring. Hopefully we can try that again in the fall. So what I'm going to do is talk to you a little bit about prescribed burning on private lands in California. I'm a forestry advisor for the University of California Cooperative Extension. So just to start off with a tiny bit of background about prescribed fire. Prescribed fire in California used to be really quite common. It was carried out by native peoples for millennia. Lightning as well started many fires. And after settlement with Europeans and Americans coming to California, those folks continued to burn as well until 1924, when it was made illegal in California and the nation. There was a Forest Service study that looked at forests around the West and found that they were understocked, and they blamed burning for that. That in fact, in the future, we might not have the forest resource that we were hoping. And so that was made illegal all over the country. However, it didn't take very many years before people started to notice some ill effects of not burning regularly. In the South and Southeast, there were effects on wildlife habitat and the bobwhite quail that wasn't happy with the new habitat, where there was a lot of understory brush coming up. And in California, we faced the same issues with encroachment into meadows and rangelands from shrub species. And so there was burn permitting started in the mid-1940s, and there was a ranching community that did burn fairly regularly. That peak was in the mid-50s, when there were at least 200,000 acres burned throughout the state. However, that declined over time. This paper that I'm referencing, Bandwagon Dunk from '95, describes some of the reasons. They said that it had to do with adjacent wildlands being developed and liability issues. And so over time that declined, although there is still some of that tradition that has persisted in more rural areas. Unlike here, in other parts of the country, that tradition continued going strong ever since the 1940s, especially in the South and the East, where significant acres are burned by private landowners. In California and throughout the West, we started to get more prescribed fires in the 70s and 80s, mostly by agencies. And right now, the vast predominance of acres burned in the West is done by public land agencies. However, in the last few years, especially with our huge wildfire seasons and destruction and increase in really severe catastrophic fires, there's become a new emphasis on prescribed fire and expansion of its use on private lands. That's where we are today. I just wanted to comment on how we know about fire frequency in the past. We have a couple of really great sources. One is tree ring studies. The picture on the left you'll see is a tree that experienced a number of low severity fires that burned by. The arrows are pointing at the years in which a fire burned and injured the tree. However, since the fire was a low surface fire, it didn't kill the tree, and the tree was able to rally its resources and heal over that scar. And so you'll see the exact years in which that tree experienced a fire. A fire return interval is a measurement of how often is common. So you take all the years there, say between 1897 and 1889, there's 8 years, and then you would average and get an average fire return interval. So we have really good data for forested systems because we have a lot of remnant trees that help us know these things. In shrublands and other grassland areas, we have less of that physical record, but there have been a number of really great studies and interviews with Native people that continue to have expertise and cultural knowledge about burning that have helped us come up with some numbers of how frequently California used to burn. So the picture on the right there is a fire return interval map. The darkest brown that you'll see there, which is more prevalent on the west or left side of the map, is a mean fire return interval of 11 years. So on average, each area acre would experience a fire every 11 years. That number gets farther apart as you go uphill. The farther you go uphill, the fewer fire weather days that you have where a fire could catch. You have more rain and cold weather, and the fuels regrow more slowly. So it takes longer after a fire for the area to carry again in a more subalpine system because there's less stuff to burn. So you can see in our Ponderosa pine belt, which is farther downhill every 5 to 12 years, and in the mixed conifer zone in the Sierra where I am, every 8 to 20 years, we believe, fires came through and cleared out smaller material in the understory and small trees. We do think that from time to time there were large fires with patches where everything was killed, but not as common as today. So this paper that I referenced below, Stevens et al., looked at all this data, tree ring data, native ethnographic data, and estimated that on average every year before settlement, 4 to 12 million acres burned. And since California has about 105 million acres, that's 5 to 12% of the state every year burning and reducing fuels. That is a lot. And even in these largest seasons that we've had of big wildfires, we've not gotten anywhere close to that. So we know that the vegetation in California was evolved and adapted to frequent low severity fires. Putting out all those fires had some consequences for our ecosystems in forested areas, which I'm most familiar with as a forester. What that's led to is a lot of small trees falling in. When trees die and fall over to the forest floor, the fuels build up and aren't burned periodically. And now we have larger fires with lots more material and heat, and that has led to much more high severity fire where most of the trees are killed. Okay, so what can we do? We hope and can anticipate methods by which we could expand the use of prescribed fire, including on private lands in California. So this is a little graph that I put together based on data from NIFC, the National Interagency Fire Center. In blue, you'll see California. In 2017, we had about 1.3 million acres burn in wildfire and something like 50,000 acres burn through prescribed fire. You can contrast that with Florida. Florida is kind of a superstar of prescribed fire. They have very prescribed fire friendly laws. And in Florida in 2016, about 2.2 million acres of prescribed fire versus much less wildfire than we experience. So what I think that does is show you that that's possible, that we could change this proportion around. And then the other point I want to make with that is that if you look at this map of land ownership in the United States, you'll see that Florida is mostly private land. The Forest Service is a light green, and most of those other colors are different public land management agencies. So they're burning that kind of scale in Florida on private lands. And in California, we have private lands that also could be stepping it up. So it's possible. It's done elsewhere. How can we do that here? I would like to start off our next poll here. Max, if you can open up my poll number 1. And I would like to see for the folks that are in the webinar, how many have experience with prescribed fire. So I don't see any votes coming in. I see that people are viewing the questions, but I don't see anyone voting. So Max, hopefully you can get that going. Oh, maybe you just haven't shared the results with me yet. So I'm going to take a little break here and wait for you all to vote. And while I'm waiting, I'm seeing a question from Wolfie. I can share that colorful fire return interval map with you. It's from a publication I worked on with the Sierra Nevada Conservancy. And there are also a number of maps available from a Forest Service publication about fire return interval. So yeah, you can go ahead and email me directly, Wolfie, and be happy to send that to you. Yes, it's fine with me if you share screenshots. Okay, so I'm seeing the votes coming in. I see about half of the people have voted. I see that it's a long list, so I appreciate that. I'll give it another minute. For people to vote. Okay. Max, would you like to go ahead and end the polling, and then I'll share the results with us? Okay, great, thanks. All right, so 29% have never burned on their property. 65% have burned piles. That's a number I was expecting because at least here in the Sierra Nevada, I'd say it's pretty common that people deal with their woody debris by piling and burning. 19% have done broadcast burning, which is great, and 7% some cultural burning, which generally means trying to promote specific cultural plants. I'm not surprised by answer number 2, which is reducing wildfire hazard. I think we have a huge focus on that right now. And I see many different objectives for why people might want to burn. I see number 2 would be invasive species and wildlife habitat and land health, which is great. And if you've not broadcast burn, I see lack of knowledge and experience as the number 1 reason, which is a very understandable answer as well. As I mentioned, there's been kind of a loss of knowledge for most people for the last 100 years. And it is a complex topic and something that you would want to have knowledge and training to be able to do. So I'm going to go ahead and stop sharing the poll results and move on to my next slide. But thank you for sharing those thoughts with me. It is pretty similar to what I was expecting. Many people that I work with have experienced burning piles on their property. So that would be the pictures on the right that are from my colleague, Ryan Tompkins, piling up material and setting it on fire as a way mostly to be rid of woody debris. People who are doing that are already taking on the liability for fire escapes. There's actually no difference in your liability based on the treatment on the right versus the one on the left. The one on the left we call broadcast burning because it's across the wider landscape. The principles are similar to pile burning, however, the conditions are different. When you can broadcast burn is different than when you can pile burn. You could pile burn in the winter as long as you had a little bit of stack that was kept dry from your weather. And it doesn't matter how moist conditions generally are because you're building up heat within the pile. Your risk, is different in these two situations. You can see on the right-hand pile, it's very, very hot. So there actually is a physical risk of hurting yourself, you could see, as opposed to broadcast burning on the left. It's hard to imagine if you fell down that in the fire that you would really hurt yourself. So those things are different. Obviously, ignition, how you start a fire in broadcast burning needs to be thought through, how you control it from burning away from you, and then how you mop up and patrol, although obviously you should be checking your piles as well. I'd say one of the biggest differences between these two methods is that for broadcast burning, you could have multiple objectives. Pile burning is very good at getting rid of debris, reducing fire hazard, but something like invasive species or wildlife habitat, that's really objectives that you can get through broadcast burning rather than pile burning. But I belabor this just to help people understand that they do already have some expertise in prescribed fire, and both of these methods are considered methods of prescribed fire. It's just that there's a different series of information and knowledge that is needed for broadcast burning. So things that you would need to know are about fuels, weather, fire behavior, and then what objectives could happen on your property. And if you wanted to be able to use it, I suggest getting experience, working with others, and then trying to identify what objectives could be met through your broadcast burning. So I just wanted to point out something maybe obvious or maybe not. The whole concept of prescribed fire means that fires are burned under a prescription. So just like if you go to the pharmacy, if you have allergies and you get a prescription to alleviate your allergies, you need to take that prescription in specific times and dosages to get the intended effect. And that's what the word prescribed in fire means. A prescription is a set of conditions that considers the safety, weather, and probability of meeting specific burn objectives. So that is when you light the fire, when you are in prescription. That's what we mean by that. That picture on the right looks like a prescription. An objective would be to burn up some ground fuels and possibly even some ladder fuels, kill a few small trees. So if that was your prescription of what you're trying to achieve, then this could be considered a situation, assuming the weather and everything is right, in which you are burning in prescription. So that's how we use the term. So in order to know if you're meeting those conditions, you need to understand some things about fire behavior, weather, a number of technical subjects that maybe it's a bit more complex than pile burning. Just in general, we all know that fire has some required components: heat or an ignition source, oxygen, and fuel. That's the fire triangle that probably many of us have learned about over the years. And then if we're talking about wildland fire, we have the wildland fire triangle. So the things that affect how a wildland fire or a prescribed fire are going to burn are things like fuels, topography, and weather. And so getting some expertise in all of these is really important for being able to carry out prescribed fire or broadcast burn safely and effectively. So I'm going to go through each of these just briefly to give you an overview, but it's a very complex topic and takes some years of experience, I would say, to get a feeling for. Topography. I think most people know that fires burn faster uphill. That's because as the fire burns, the heat and the smoke rises and preheats the materials above. And so you can expect, if you have a sloped property, that for the most part, fires will burn more quickly uphill. And you can control the speed by starting at the top and burning your way down, depending on wind direction as well. So topography is a super important component of how you plan a burn. Fuel characteristics are really important. So I have two pictures here on the right. You can see some dead trees, some large fuels in the top one, and not a lot on the forest floor on the bottom one, but there are some live small trees. So understanding fuels and being able to classify them is important to be able to understand how these two different areas would burn. We classify them by their load. Obviously, more fuel leads to more heat. It can have more severe impacts on the vegetation that you want to leave behind. The size of the fuel, just like in your fireplace, you start with small stuff because it ignites quickly and burns quickly, and then you can get the logs going. So fuel size. Compactedness is an important characteristic. For example, that is why we are doing a lot of mastication all over the West to not remove the fuel, but to cut it up in smaller pieces and make it compact so that oxygen can't easily get in, and it slows down the burning process. Continuity. A lot of fire and fuels reduction projects are being done to reduce the continuity of fuels. So in the lower picture, you might take out the small ladder fuel trees so that they cannot convey that fuel, that fire, to the trees above. And then fuel moisture. And fuel moisture is very important, especially if you've ever had a fireplace and you let your fire get wet, you know, you can't really start it very well. Fuel moisture is affected by a number of things, including temperature, humidity, and shade. So the fuels in the shade usually are more moist because they're not drying out from the sun. Also the size. So we classify fuel size according to how quickly they dry out. So a 1 hour fuel has a size of less than 1/4 inch in diameter. This would be twigs, leaves, mulch, litter, pine needle, pine straw, you might call it. And what the 1 hour means is that within an hour, the moisture should be mostly equilibrated with the conditions outside. So whatever the humidity is or the temperature. So the idea is that pine needles, they could be wet, and in about an hour, they could be dry enough to burn, as opposed to a log of 3 to 8 inches. After it's rained, it's soaked up a lot of moisture, and therefore it could take up to 1,000 hours to equilibrate with its environment. So if you're burning right after a rain, you would not expect those to burn, right? So that's an overview of the fuel characteristics. Weather. Weather obviously is super important to fire behavior. There's a number of factors to keep in mind: wind, temperature, relative humidity, and precipitation. So obviously windy days can make the fuels drier, can take embers and broadcast them farther. Temperature changes throughout the day. So that's the first line on my figure there in red. So you can see that if conditions were kind of wet, you might want to wait till the warmest part of the day. If conditions were dry, you'd probably want to do it during the coolest part of the day because there is a relationship with humidity. And then precipitation clearly increases the fuel moisture and slows down burning. One of the main things that you could do to really if you want to be involved in burning on your property, is to become a weather geek. I never really was before being involved in prescribed fire. I don't know, I just didn't want to constantly talk about the weather with people, but now I love talking about the weather with people because it's really important. So I encourage you to start really monitoring these types of things around your property. One way you can do that is by looking up a remote automated weather station, or RAWS. Now, this is the RAWS station that's very close to UC Berkeley's Blodgett Research Forest in El Dorado County. And I pulled this data off yesterday. You can see this is everything from May 5th, from 1:36 in the morning to 6:36 p.m. when I was working on this talk. This is a point in space that's not too far from that station, so it's a good reference point. And what I want to really point out here is it has fuel moistures. Do you see the column at the top? It's 4%, at the bottom it's 8%. So it's giving you an estimate of how fuel moisture is changing over time. And so that is super important to be able to time a prescribed fire, write a prescription, and really understand how things work on a property. This is a ways away from the research station. So Rob York, who was the manager there, also installed some local data collection methods, including fuel sticks, so that he can really see how that works. Also, you know, this is going to vary on north and south facing slopes, but in general, this is a great index to show you how the fuels are working in your area. So this is a great data source to start looking up and monitoring over time, so you can get a feeling of when might be the appropriate burn windows in, you know, on your property. Okay, so then I wanted to talk a little bit about different types of fires. You can quantify the height or the rate of spread, or you can just describe how the fires are doing. So right here, here's a photo from a burn that I got to participate with the Humboldt County Prescribed Burn Association. In this case, the fuels were a little wet and we have smoldering behavior. It did do a little better later in the day and in places where the sun was better. But generally we want a little more consumption than this. Here's a creeping fire. It's burning with low flames. It's not burning very quickly. It's pretty moist. I think this was from the burn we did at Blodgett in February with workshop participants. It was a little wet, but we did get some consumption of 1 and 10-hour fuels, which are the small litter and the little twigs. And that met the objectives of the burn, which were to reduce those fuels for the future. Here's a surface fire. That one's burning a little more nicely. That's probably later in the day, the same day, when the temperature went up and humidity went down a little bit. There is heat coming up. There could be scorch on the crown, but in general, it's staying on the surface and is giving us some good consumption of our fuels. At some point, we can have transitioning to single tree torching, starting to burn up this tree. It's getting a little warmer. And then here's a picture of single tree torching. It's literally one tree burning up. It's not a crown fire because it's not going to convey across the canopy. This could be within prescription. I did describe earlier that we have more trees than we used to, and so actually being able to kill some trees through prescribed fire could be, you know, what you're hoping to do. It gets exciting too. And then some more vocabulary for you. A spot fire. This is actually during the Angora fire here in 2007. The house was already involved, but here was a spot fire that came from an ember from off the main fire front, and so the firefighters are suppressing that. That is not the same thing as an escape or a slop over. So here's a picture of a slop over. The prescribed fire was on the right. You can see there's a control line and fighters along the ridge line, and right where the folks in the front are bending over, there was a slop over. So it got a little bit beyond the line, but it was contained at that point. An escape is when a fire burns beyond the landowner's property and you have to call in additional resources to control it. Escapes are rare, but they do happen. But slop overs and spots and those sorts of things are not uncommon, and that's one reason that it's important to have a patrolling plan and a good holding crew. So those people that are there on the line are the holding crew, and they've gotten it under control. So that was just a really quick overview of fire behavior in order to really set up this concept of developing a burn plan. These are the components of the new CAL FIRE standard burn plan for California. It does require a lot of expertise. If you maybe were burning a 1/4 acre in your driveway, you might not need a burn plan, but as things get more complex and as you burn larger areas, it's important to have a plan, especially if something went wrong, to show that you were following your plan. So it includes things like units and your objectives, what you have on site, your prescription, what conditions you're planning to burn on, how you're going to manage smoke and ignite the fire and hold it, and then mop up and patrol it. And so it's a pretty complicated, task if you haven't had experience before. Some of you may have had experience. So here I just wanted to touch very quickly on the options for implementation. So there would be some folks who could do it themselves. There are some who could hire a prescribed fire contractor. There is quite a shortage, but they do exist. You could sign up for CAL FIRE's Veg Management Program or the Natural Resources Conservation Service EQIP program. And all of these will be touched on later on in this webinar series. So I'm just giving you kind of a teaser. Or you could work with a Prescribed Burn Association. We have a great talk about that from our colleague Lenya Quinn Davidson. So, you know, understanding all the things that need to be understood to do this well, you know, where do you fit in there? We've been asking people that at our workshops. So I mentioned earlier, we've been doing workshops in the Sierra Nevada since 2018. We would have liked to done this in person. Since spring of 2018, we've run about 319 people through these workshops. And here's their answers to who they were, kind of like we asked you at the beginning. Lots of landowners, homeowners, Fire Safe Council folks, foresters, some federal agencies, conservation organizations, and others. And basically we put them through the 2-day workshop and do a pre and post test and ask them, you know, what they're interested in doing. Here's one of the group after we did our demonstration burn in 2018. And basically there's a lot of enthusiasm for prescribed burn associations. I haven't given you much detail on what that is, but generally it's burning with some experts and very participatory so that people can really build up their own expertise as well. There's a lot of enthusiasm for signing up for VMPs and EQIP, burning with families, and hiring independent contractors. So ideally we'll be learning all about those options as we move forward. So that's what I've got. Thanks for listening. Yeah, Rebecca, I'll turn it back over to you.
Great, thank you, Susie. Hope everybody enjoyed that presentation, and I know we have a few questions in the Q&A, so just reminding everybody we will address those at the end after our next presentation. But Susie, if there's any that you think you want to address by texting or putting a written response in there, feel free. In the meantime, we're going to move on to our next presentation, which is from UC Cooperative Extension Livestock and Natural Resources Advisor, Dr. Fadzayi Mashiri, coming to us live from Merced. And Fadzayi will be talking about fire for managing weeds and invasive plants. So as a reminder, please continue to submit any questions you have for our speakers through the Q&A box. And with that, I will turn it over to Fadzayi.
Okay, can you hear me?
Yes, hear you good.
Let me see if I can turn my video on.
Great, we see you.
Okay, so good morning, everyone. Thanks for coming to our first session of this series. We're really excited to have such a good response to this webinar series. And as Rebecca said, my presentation today is going to focus on the use of fire on rangelands for invasive plant control. But before I proceed, I just want to at least acknowledge some of my colleagues who have contributed materials. to this presentation that I'm giving you today. It's Rebecca, who is our moderator today, as well as Jeff Stakehouse, who is a livestock and natural resources advisor up in Humboldt County, as well as Caro Neto, who is a natural resources advisor in the Central Sierra counties. Okay, so what I'm planning on presenting today is just to at least follow up on what Susie has presented. How can we use some of the principles of fire ecology and fire behavior in really understanding how we can apply this fire on the ground for rangeland management goals that we may have. It could include vegetation management, but my presentation is going to mostly focus on weed control. So the topics that I'm going to cover, like how are these rangeland ecosystems adapted to fire? And then I'll just kind of repeat what Susie covered already, the trends of fire use on our landscapes over time, and I guess looking at where we are coming from, but hoping that where we are going is going to actually be more use of prescribed fire on our landscapes. And then I'll touch on what are some of the important considerations to plan so we can use fire sustainably in these natural ecosystems. And then just focus on the weed species. I'm not going to go into details about so many weed species that we're dealing with, understanding that we have audiences from such a diverse places, ecosystems. So I'm just going to look at general principles of invasive potential of weeds, and then give a couple of examples of how we can use this fire behavior in weed control, hoping that from those examples, you can kind of understand how you can apply fire prescription in some of the weed species that you deal with. And then after that, I'll touch a little bit briefly on post-fire management strategies, and then wrap up, then we can go to the question and answer session. So what are some of the characteristics? What is it that makes some of the rangeland plants fire adapted? So there are several characteristics or strategies that plants do to actually survive fires. And one of the factors is how they avoid at least being in contact with fire, at least fire that would result in the death of the plants. And one of the examples that I'm going to share is that of annual plants, which, because the only way they can actually survive into the next year is through their seeds, they tend to ensure that they mature, they grow, at least set their seed and mature and drop their seeds before the regular fire season of that area. And that's mostly because when the seeds are dropped onto the ground, the fire normally that comes through on grassland fires or rangeland fires is not high enough on the surface to actually kill the seeds. So that way those seeds can survive and be useful to propagate in the future seasons. And then we also have woody plants that have thick barks, like oak, some of the oak species that will use the thick barks to actually protect their cambium. So the plants, the cambium is protected and won't be affected by the heat, thereby surviving the fire. The other way some of the plants, especially perennial plants, grasses, shrubs, is also through what we call tolerance of periodic fires that come through. But what is really important for us to understand here is the fire intensity has to be below a threshold for each individual species for them to not be killed. So if the fire intensity is too high for a certain plant species, then even though they are adapted, they might eventually die. So for perennial grasses, the way they tolerate the fire is because they have this growth system where the growth points or the meristems of the grasses are mostly at the surface or below the surface of the soil, and that way the fire can come and burn the aerial parts or the leaves and the stems of the grass, but the meristems or the growth points would not be affected. So I just wanted to, I don't know if you guys can see this sample that I kind of collected just to illustrate what I'm talking about, where you have the fire coming and consuming this whole part of the plant. But as you can see, where most of the grasses are growing is mostly at the base. Most of the growth is coming from the base, or all the tillers are mostly coming from the base, especially if they are bunch grasses. So the fire can come and consume all this part, but the areas where you have most of your growth happening is actually intact and protected by the soil. So that prevents them from actually dying from the fire. And that is really important for perennial plants because they do not propagate too well with seeds like what annual plants do. So they have to survive the fires that come through periodically for them to at least be able to sustain themselves and this fire in these ecosystems where fire comes through. So in all the ecosystems where we have perennial grasses, there is some tolerance to fire that exists there. So we also see the same strategy from shrubs where once the fire comes through, you can burn the whole stems upwards, but you can see most of the shrubs sprouting and persisting, or sometimes even thriving better after the fire because there's less competition. And there are also certain plants that have seeds that have thick seed coats. And the whole reason is they want to wait for a season where fire comes through, breaks the thick seed coat on the outside of the seed called scarification. And that way the seeds would be at least released and be able to start being viable and actively able to germinate. So it's almost like these seeds are able to protect themselves in adverse conditions and only be released after a fire comes through and scarification happens. One good example in our area is baggrass, or which has that system going on. And then as I'm sure most of you know better than I do, acorns actually favor the presence of smoke for them to produce more acorns in these ecosystems. So here is, with these graphs, I was just trying to kind of talk about issues that, or things that Susie has already mentioned about how areas that were burned under prescribed fire was declining over time. Both are done by ranchers, permitted ranching, prescribed burning, as well as a vegetation management program, or VMP, through CAL FIRE. And with the with this graph through the rangeland permitted burning, you can see how the acreage under prescribed burning really declined between maybe the 1950s through 1977. And then you can see similar trends happening with the VMP program also. Acreages are declining over time. So for me, I'm really excited to see us coming together now with an understanding that we need to bring prescribed fire back on the landscapes to at least use it to manage our vegetation, as well as some of these invasive species, and fuel management as well. So this is really exciting times. When I started this job about 6-7 years ago, one of the issues that the ranchers that I work with were telling me is that they're really interested in using prescribed fire on their landscapes, but they were really prohibitive conditions. So I'm excited to see us coming together and really getting this ball rolling towards in a time where we can hopefully see more acres burnt using prescribed fire. This slide here is just a reiteration of the previous slide that I shared with you, showing, and it's pretty much similar to what Susie shared with us in a presentation. So what this, the tree rings here show is that between 1837 and 1897, we can see that there was the mean fire return interval of about 15 years. And after 1987, this whole sample actually records no fire coming through for 111 years. So that's such stark contrast from what we would want to see in our ecosystems. I can say this is sample was from California, but at least it's just an illustration of how much less prescribed fire is happening on our landscapes right now. So I also did a search and found some more information which shows that pre-1860 grassland and oak woodlands, the fire return intervals were about 10 years. And then after, in the 1900s or in the 20th century, the return interval jumped to 78. And then in the ponderosa pine, the pre-1860s, the return interval was 4, and it jumped to 192 in certain areas. And the foothill chaparral, the return interval before was 30, but I couldn't really find any record or information to tell me what the return interval was in the 20th century. But I'm kind of guessing around the 78-year mark because of the way the grasslands and the foothill chaparral are kind of close to each other. So in general, we can clearly see that over time we have seen a decline in fire frequency on our landscapes. And this is mainly due to fire suppression, which of course has resulted in increase in fuel load on our landscapes, which in turn is resulting in all these catastrophic fires. And the other reason that we can also think about is presence of grazing on the landscapes, which sometimes reduces the amount of fuel on the landscapes and reduces the way the fire carries across the landscapes. But there's been also mixed results that are coming from what we are seeing on the, especially in our state, with most of the grassland areas where grazing still exists, having so much fuel left over in certain times that we have seen catastrophic fires actually emerge from these rangeland ecosystems that are working or being grazed by livestock. So what has become really apparent to us as researchers is how can we really get to a point where we can understand what levels of biomass needs to be left on the ground to maybe significantly reduce fuel load and reduce fire risk. But at the same time, there are also other areas that have seen the fire frequency go in a different direction, where fire frequency has increased higher or actually existed in areas which normally you don't see fire happening. And these are areas that are affected by invasive species coming in like sheetgrass in the Western United States. And because of the more higher fire frequency and more intense fires happening in these less fire adapted ecosystems, we are seeing a decline in native shrubs. And one really good example that I at least experienced personally is the invasion of the Sonoran Desert by buffalo grass and lemon lovegrass. In Arizona, when I was doing my PhD, there is a lot of fine fuels that is emerging because of these non-native species in these areas. And as a result, they are really negatively affecting the desert ecosystems that are not fire adapted. So moving on, I just wanted us to really think about what, just like any management tool that we want to apply on our landscapes, we really need to plan and think through what could be, what is the approach, what are the strategies, or what are the constraints, what is it that we need to do right, or what can go wrong if we apply a prescribed fire on our landscape. So here I have some factors that we need to consider before we can apply prescribed fire on the landscapes. Think about the fire regime, think about the fire frequency. How often is the fire going to come through, and how much is it going to impact the targeted weed species versus the preferred species that we want to promote in the areas that we're managing, as well as the timing of burning. When is the most appropriate burning time when the targeted species or weed species is susceptible to burning and being negatively affected, while least strategically not affecting the native or preferred forage species. And also the fire intensity. What amount of fuel load do we need to burn hard enough to kill the weed species, but not hard enough to actually negatively affect the desirable or native species? So we really need to think about all those things and have an understanding of how can we optimize our prescribed fire regime to ensure that we are affecting the weeds that we want to control, but also not negatively affect the native or desirable species. In the same token, here I have a graph which shows the phenological stages of both the desirable species as well as the non-native species that we mostly deal with in the ecosystems that I work with, medusaid, barb goldgrass, and yellow star thistle. So in general, what we have seen is that native and desirable species mostly progress through their phenological stages a little bit faster than non-native weed or invasive species. So you would see the desirable species growing and then starting to flower a little bit earlier in early spring and setting their seeds and dropping their seeds in April, while least medusaid and barb goldgrass and yellow star thistle they stay green a little bit longer and start setting their seed end of April, beginning of May. So at least we have that, at least differences in the phenology of these species, which might actually provide us with a window where we can actually target the non-native invasive species for prescribed burning. The other considerations that we need also to think about is the policy. We need to be in compliance with the permitting that we need to be able to do whatever kind of burning we are doing. The resources, do we have all the manpower in place? Do we have all the equipment that we need in place for us to actually be able to bring fire and do it in a safe way? We also need to also think about follow-up treatments. How often can we burn, which is fire frequency, but can we also bring in new tools for burning in a form of some kind of integrated weed management program? So Max, can you share our next poll? So here, I just wanted to kind of get an idea of what are some of the weed types that you have seen in your areas or you are dealing with in your areas. Okay, it seems like most of the people have voted. And okay, there's still a few trickling in. So at least from what I'm seeing, most of the problem weed species, you can share the poll results, Max, are mostly annual forbs and annual grasses, which is pretty expected, with yellow star thistle being almost everywhere, as well as some of these annual grasses, especially on rangelands, medusa and barb goldgrass and cheatgrass being some of the main ones that we have seen in our area. But one of the things that I just want us to keep at the back of our minds is some of the constraints that come with trying to use fire to control perennial plants. So I guess I'll move on and start really looking at a couple of examples of weed species that at least we deal with here in California mostly. And medusa is one of the biggest ones that we deal with on our rangeland systems. So medusa is in an annual grass, and it was introduced to the United States in 1880s. And so far, it has established itself in more than 2.5 million acres in California and more than 5 million acres in the United States, mostly in the western states, but there are also a few areas in the eastern states where medusa head exists. This plant mostly exists in ecosystems which receive between 9 to 12 inches of precipitation. So medusa head and barb goldgrass, their invasive potentially the way they invade ecosystems are pretty similar. And their invasive potential stems from them being early germinators. Because they germinate early, it allows them to actually be able to establish their roots well before the other desirable species have established their roots. So it gives them a competitive advantage towards being able to absorb more moisture and nutrients when the other plants start germinating and establishing their root systems. And they stay green longer. And this is really an advantage, especially in areas where rangelands are managed as under stocker cow systems, where most of the people bring in cows, let's say in October, and then they ship them out end of April or mid-April to early May. And that is a time that most of the medusaid seeds haven't even set yet, while at least the native and desirable species seeds have set and are likely to be grazed on by the animals, sparing the medusaid seeds. So it gives them that competitive advantage by having the medusaid seeds at least thrive when the animals are taken out of the rangelands. And also, as all annual plants, they produce a lot of seeds. They are higher inefficient for water use. They need less water for them to actually produce a pound of biomass. So, and also because of the low nutritional quality of medusaid is low in protein content, and the rate at which the protein content in medusaid declines as the plant matures is way faster than the more desirable species. So because of that, animals would tend to not graze on it as it matures, which protects the seeds from not being grazed. And also it's high in silica content, which reduces digestibility and also reduces decomposition. And because of the combination of those factors, because it's not grazed, it tends to create a patch on the surfaces of the areas where it's colonizing, and creates a monoculture of medusaid, because it's creating an environment. It's creating that positive feedback, which prevents other plants from being able to even germinate in those ecosystems. And then because of the awns on the seed head of medusaid, it can also actually poke the faces or the eyes of the cows and create mechanical injuries. So what we would really expect for fire to do as a tool to control medusaid is to reduce seed production, or to at least kill the seeds that have been produced, which reduces the supply of the seed to the seed bank, so depleting the seed bank over time. And then it also consumes that thatch that is on the ground, releasing nutrients and also allowing other desirable plants to at least be able to germinate and thrive. So here is that graph again, where I was showing you about the phenology of the different types of plants, native plants and forage species versus medusaid, barb goldgrass, and yellow star thistle. So because these invasive species are green for a little bit longer after the native species have dropped down their seeds, this at least allows us this area, which is circled in red, to at least allow us to burn at that time when the seeds of the medusaid are still on the seed head, while least we are using the fuel, the dry fuel from the native and desirable species. And the effectiveness of fire on medusaid has been seen to actually be up to 90% seed reduction after a good fire has gone through. So here is just illustrating how on rangeland fires, having the seeds on the ground before fire comes through is really important for the desirable species to be able to survive. So surface fire temperatures are lower than canopy fire temperatures of about 1200. And the lower temperatures on the surface are not normally enough to kill the seeds. And this at least allows the desirable species to escape the fire. Whilst because the seeds of the medusaid are still on the head, can be killed by the higher temperatures on the canopy of the grassland fires. Another study that kind of supports this is a study that was recently done by Jamie Bartholomew at Berkeley, who also kind of identified that the moment the awns or the spikes on the head of the medusaid are burnt, most likely the seeds will not be viable to germinate the following year. And this is just to kind of at least make us think through and understand that the results of fire control on medusaid sometimes is not consistent in all environmental conditions. This was a study that was done in the early 2000s, and the sites were located in different ecological areas, warmer, drier areas, Fresno and Yolo, as well as cooler areas, higher elevation areas like Siskiyou and Modoc. And what they found is burning at the same time in spring was really effective in Fresno, but because of the environmental conditions in the higher elevations, there was too much moisture in the grasses, as well as low fuel in the Modoc area that didn't burn enough to actually impact the medusaid. The reverse actually happened where they saw in year 2 having more medusaid thrive than in unburnt areas. So environmental conditions are really important to keep in mind while we try to use fire as our control tool. And then moving on to yellow star thistle. Yellow star thistle is an annual forb, and it mostly occurs in disturbed areas with altered fire regimes or low fire regimes. And yellow star thistle declines as diversity increases, but once the fire has stopped, you also tend to see yellow star thistle comes back. So it really favors areas where there's low fire return interval and also high disturbance. And this table here is just to illustrate how consecutive burning can actually really deplenish the amount of seeds that are in the ecosystems or that are dumped into the systems, and also the seedlings that germinate out of the available seeds that are dumped into the seed bank. So fire can be effective if done well, but the most important thing is also follow-up treatment to make sure that the yellow star thistle doesn't come back once the fire stops. So in terms of timing, burning can be done in early summer. And in this case, what will be the goal is to actually kind of burn the yellow star thistle while it's still green, but it will dry after some time if the fire was hard enough. But the most important thing is to make sure that the yellow star thistle is at most bolted, but the seeds are not set, because even if you burn a little bit later, even if the seeds are if the plants are going to die, it might give them an opportunity to at least mature before the plant actually completely dries. And then the other timing is also after seeding. The goal is to actually kill and consume the seeds, because if the seeds are still not consumed, they'll be viable and able to come back and germinate the following year. So follow-up treatments is really key, using herbicides, grazing, and follow-up fires. And then just touching about what I mentioned earlier about perennial plants, perennial grasses really, they can be killed by fire, but for the most part, normal grassland fires, perennial grasses actually benefit from them and stimulates their growth, which is the reason why fire is actually used for improving forage production on perennial grasslands rather than actually controlling them. And shrubs and chaparral, fire is not the most effective, but at least you can go in there and burn the shrubs and open up the areas and then have that short-term effect. But the most important thing, it would be to at least have follow-up treatments, as well as more frequent fires that will come and maybe continue to open up those areas too, especially in areas where shrub encroachment is happening into grasslands. A little bit of fire frequency coming through or regular fires coming through would help prevent reinfestation. So here is just mentioning about desert ecosystems not being fire adapted. But because of the introduction of non-native species in some of these ecosystems, we have seen really high fuel presence in some of the desert ecosystems. And because of that, up to 97% of mortality of native species has been seen, although certain species can resprout as well. But fire in these ecosystems is pretty, has negative impact on the landscapes. With this slide, it's just an illustration of how when fire comes through actually knocks the weed abundance down and gives us an opportunity to at least come in with follow-up treatments. But if that follow-up treatment is not done, sometimes you would see the non-native plant species coming back and thriving or getting to the same levels, or sometimes, as this example shows, even higher than where it was before, because maybe the fire also impacted the competing desirable species or non-target species. So it's really important once we get in there and burn to make sure that we continue to follow up with some kind of follow-up treatments, whether follow-up fire treatments or follow-up integrated weed management strategies that we can bring in. And then this is my last slide. What I just wanted us to really think about using prescribed fire or bringing prescribed fire for vegetation management or weed management on our landscapes is to look at it, as Susie was saying, because we haven't been doing this as much, we have kind of lost that skill and knowledge base. So go into it and look at how can we actually gather information to learn from the activities that we're doing in a more adaptive management approach, so we can make decisions based on the results or on the monitoring results that we have. So let's use whatever practices we're going to start right now to actually learn from it, and learn from it by collecting data and making sure that we understand how our ecosystems work under the prescribed fire regimes that we are proposing or we are using on our landscapes. So for example, after using fire, you can do some kind of adaptive grazing management to benefit the perennial grasses that are that exist on that area, or also adjust grazing intensities to accommodate the lower forage production and shorter growing periods that come immediately after fires come through. So that's it from me.
All right, thank you, Fadzayi. I hope everybody feels like they learned something. I always learn something from that talk, even though I've given a version myself. We do have a few questions from everybody, so I'm really excited to get through a few of them. And because we are about 10 minutes before the anticipated end of our webinar, we could go a little bit long, but if we don't get to every question, we'll be sure to have written responses once we post this webinar. So we'll start with one of the earlier questions, a few that might be good clarifiers. This was addressed to Susie. Somebody asked if everybody knows what a ladder fuel is. So if you could give a brief description of what ladder fuels are.
Sure. The idea behind a ladder fuel is that it's in between a layer, usually in a forest or, even around your house. If you have shrubs underneath trees and a surface fire comes along, then the shrubs burn and burn up the tree and then maybe catch your house on fire or catch more of a forest on fire. So a ladder fuel could be a tree, it could be a snag, it could be a shrub. It's just its positioning that's referred to by that term.
Perfect. Thank you, Susie.
Sure.
I'm going to bounce around a little bit so we get a variety of questions asked today. Somebody asked, and I think this will apply to both Susie and Fadzayi. I live on the coast and most of my land is very steep. Is there a maximum slope on which prescribed fire can be used?
I'm not familiar with a maximum slope, but obviously that makes the burning more complex. However, it depends on the conditions in which you choose to burn, right? So if you're choosing to burn that in a kind of a moisture period, you might not even really get a good fire going. And slope could help you burn. Flat parcels can be harder to burn because there's no preheating, and sometimes, if it's a moist condition, you couldn't get the darn thing to burn, whereas a little slope could help you. So I would not say that. I would say that it might make it a little more complicated. So I don't think necessarily that would be an issue. I see that Len Nielsen from CAL FIRE is adding a comment, which to my panel, my little thing that says slope might impact erosion issues that go along with the burn, and that's certainly possible. So you might need to do different, follow-up erosion control, but I would not count it out because of slope. I don't know if you had a comment, Fadzayi.
I think you covered it well, Susie.
Okay.
Great. All right. This question relates to that timing chart that you showed, Fadzayi. Is there any observations of climate change impacting plant phenology and the timing of invasive and native plants? And can we expect that treatment window to remain available?
So actually, we have seen that climate change really impacts, maybe not necessarily climate change, but variability in climatic conditions every year impact the timing of the different phenological stages of the plants. But in general, you would expect the native and desirable species to still mature earlier than the non-native medusa head and barb-gourd grass. So the window is still going to be there for the most part, except if there wasn't a lot of growth that happened. But the timing, the timing would slightly be different depending on the precipitation patterns that happened in that specific year. So the graph that I showed is just kind of showing typical seasons when you'd expect that to happen. But in every year, the most important thing to think about when you're trying to apply this prescribed burning is to actually look at it from the phenological stages of the plants that you're trying to target and protect.
Great, thank you. All right, here's a question about chaparral systems. Is prescribed fire a solution adapted to fight invasive species in chaparral where wildfire return frequency is already higher than ideal to support chaparral's biodiversity?
I feel unqualified to answer that question as a forester. I'm sorry to say. I'm sure many opinions could be found on this topic.
We had a few responses in the Q&A as well. Jared Eldern comments that it depends on each specific chaparral site. And I think that is something that maybe this attendee could follow up with the presenters later so we could get a little bit more information.
Yeah,
Okay.
that sounds, yeah.
Perfect. All right. We have a question for you, Susie, about the fire triangle.
Sure.
This person has been introduced to a square of fire in that there's a fourth variable of time. Can you explain how you perceive the triangle of fire versus this variable of time as well related to fire behavior?
Well, that's interesting. Someone with some shapes has been thinking that through. I have not seen a square, but right, I can try. Topography, I don't think would change over time. Weather and fuels could change over time, right? So weather's the most changeable item on that list. Fuels will change according to weather, but if you're in the middle of a prescribed fire, I'm assuming that's what you're talking about. The weather variables and the fuels drying are factors to keep in mind. Absolutely, it's really important. So I think I showed some graphs that looked at temperature and relative humidity change over time. So yeah, if you wanted to add a fourth layer, you would really want to think through when ignition would start and when it needed to stop in order to keep it within prescription. And that kind of weather forecasting is key for that. So like I said before, being a weather geek is a really great trait in this activity.
Great. All right, Fadzayi, we had a few specific questions about particular weed species that folks would like to manage. So I'm going to lump them all into one question so that you can answer however you think is best. We have questions about the conditions for burning Medusa head, Italian thistle, French broom, and Detrichia, which has the common name here of stinkwort.
So what's the question?
Folks want to know, is burning effective on these species and how do we do it? And if there's any resources you want to refer folks to, I think it would be great to share those. We can also type responses with that resource if there's something you have in mind.
So Medusa head, stinkwort?
Yes.
And what is the third one?
There was French broom and Italian thistle.
So Italian thistle, I would kind of lump it together with yellow star thistle. And then Medusa head, I think we kind of talked about those conditions. All you need to do is to make sure that there is enough fuel for Medusa head to burn. But even more so when you're burning forbs that have high in water content, like Italian thistle, stinkwort and French broom, I have no experience really any information about burning those, but I can definitely follow up with you and give you more information after doing a little bit of research.
Great. All right. In respecting everybody's time, I think we'll go to one more question and then we'll see if anybody else wants to stay on a little bit longer. I think this is a really good question for both of you that just came in. How can landowners who already burn help with research about prescribed burning?
Well, that's a good question. I would probably, it would depend how often the burning happens and under what conditions. Probably identifying people in the research community who are the most interested in that veg type and those questions would be a way to go. So if you send me some information, I do know a number of researchers, I could run it by them. In general, I think it's less likely because, for experimental purposes, you really do need to have some control over timing and other land uses. I know we've done research on private lands with larger landowners, Blodgett, and some utility districts. So, I mean, it is possible, but there is, a lot of complications for doing that kind of thing, I guess. So probably an email would be the way to go. I don't know, Fadzayi, do you have another comment on that?
Yeah, actually, I feel like now that we're starting to go into more prescribed burning, I think it'll be interesting, at least in my mind, to have access to some of these sites where burning is happening, to just kind of understand how fire is happening under different conditions. One of the little trials that I'm actually working on right now is looking at different locations in Mariposa County where VMP burning has happened in different elevations, and kind of looking at how effective it has worked in those different sites because of the different conditions. It's not going to be an experimental design, but at least it can provide us with some insight as to how the different conditions under which the burning happened actually has an effect in effectiveness of weed control. So just like what Susie said, I think it'll be interesting for people that are interested in this, getting in touch with us, and us just kind of brainstorming and see if there's any way we can actually work with you and produce some useful data for us.
There you go. If you are a range person with a VMP in Mariposa County, there's someone interested. And there could be other people interested in other locations. So I would just say again, yeah, reach out to us and we may check in with our network on whether or not there's an interest in that location and that resource.
Great. Well, I do want to honor everybody's time, so I will wrap up now. Thank you all again so much for joining this webinar. It is the first in this series, so please do come back every Wednesday for the next 4 weeks. We'll be having seminars on planning and permitting and all topics related to prescribed fire. Once you exit the webinar, you'll be taken to a survey, and we would really appreciate your feedback so that we can continue to improve on this format. And we hope to see you again next week at the same time. Now, if the speakers are willing to, we could continue answering a few questions for anybody who wants to hang out for maybe 5 more minutes so that they're in the recording.
Sure.
Sure.
Great. Let's see. So we had a very thought-provoking question about a single tree torching that you had shown a photo of, Susie. That this person asked, you know, an example of a single tree fire was given that was not turning into a crown fire because the fire wasn't transmitting, even though the rest of the crown looked very close. They're curious to know under what circumstances that's safe.
That's safe?
Yeah.
Okay. Well, yeah, I'm not sure we always know exactly what's going to happen when we have a fire climbing up into the tree, but I can tell you from research that it's important to have a heavy layer of ground fuels in order to sustain canopy fire. So the actual dynamics of the fire being transmitted across the canopy is somewhat complex. Wind would be important. I didn't see any wind in that picture. Dry fuels around you, and then a layer of fuel in the understory. But that's probably the edge of my understanding of fire dynamics. So yeah, that's about all I can say there. If you are really interested, I can try and talk to some of our fire scientists and lab people who look at those questions more specifically.
Okay, great. Let's see. So we have a few more questions from the first presentation. There was one question about how to use the RAWS data, and this person specifically lives very close to Blodgett and was wondering if the RAWS data from Blodgett would be accurate or if they need even more local data if they're about 12 miles away.
Well, you can go onto the RAWS remote area access remote weather station and website, and you'll see a map of all of them. So I would definitely choose the closest one, and then you want to think through whether or not your property is in a similar topographic situation. So distance could be important, side of the canyon that you're facing, if there's a canyon aspect, all those things would affect how your property's fuels and weather would react compared to the RAWS station. So I would definitely choose the closest one from the map. And then if you have that ability, Blodgett's a pretty big research facility, so they do collect lots of information, and over time they've been able to understand the typical differences between RAWS and their property. I think putting out, you know, a rain gauge is not a big deal. You could do something like that. You can also purchase some instruments that look at fuel moisture they're called fuel sticks. Possibly Rob will talk about that when he gives his talk later in this series. So it's a good index, but then you want to overlay your local expertise on your property over time, and you know, even with a thermometer, start to understand the differences between the RAWS station and yours, and then that can give you an indication of, you know, maybe my fuels are 2% moister or drier, or it's always 5 degrees more. You know, that remote data can help you interpret what's going on in your property. That's what I would suggest.
Great. All right, and then I think we have one or two more. One of them asks about the effect of prescribed fire in dry areas like Great Basin systems that have native plants. And they're mostly concerned about the ability for native plants to recover, especially when they are cultural resources that are used by tribes, and that drought and climate change are exacerbating the ability of these native plants to recover. So I don't know if either of you have comments about that in particular.
Oh,
In this area, but it sounds like an important issue.
yeah. I would just maybe talking in general that with concerns like that, I think it will be really important to just look at it from how can we learn from our ecosystem and what kind of fire intensity, fire frequency can be handled by that landscape. So I don't think it's just the fact that there's fire coming through, but I think the types of fire or the types of fire that is coming through or being implemented there is actually the most important thing.
Sorry, I was having a slight technical issue over here. That sounds great. I think that will be helpful. Okay, we had two other small questions. One asked about whether broadcast burning is effective to control perennial pepperweed.
No, it's not. So like what I mentioned about most perennial plants using prescribed fire for control of perennial plants is really not going to be effective. With perennial pepperweed even more so, because it has, at least reproduces vegetatively, so it is really high. It will be stimulated to grow even more by pushing fire through it rather than any other method of control. Prescribed fire won't work for perennial pepperweed.
Okay, always good to know when there's a definitive answer like that. And then the last question that we haven't really talked about yet was asking, somebody noticed that we had a variety of partners going into this webinar series, and they were wondering if we have contacted or worked with the Intertribal Timber Council on Indigenous fire methods. And I'm not familiar with that group, but maybe Susie or Fadzayi are?
I am not, although we have made connections to the Indigenous Fire Network. And we've had collaborative workshops with some tribes. We hope to continue to do that in the future. And I believe that with the last talk with Ron Good and Jared Aldern moderating, that we should bring that question up there again. We'll be talking a lot about tribal values, cultural birding, and kind of the ecosystem of all of that. So hopefully you'll come back to that topic.
Great. Well, that actually resolved all of our open questions. So I think with that, we can probably stop recording and take a break for lunch.
Sounds good.
Oh, Right.
Thank
Thanks,
you both.
Rebecca.
I think
Thanks,
that went
everyone.
really well.
Thank you. Thanks everyone for coming.